In this video, I'm going to demonstrate how it is that we'll map one figure onto a similar figure. The first thing we always have to do, well, technically you don't have to do it first, but it makes it much easier, is if you dilate first. We want to make this one congruent to that one, and then we'll just use our other transformations, our congruence transformations, to map the pre-image onto the image. So the first thing we need to do is dilate, and we have to figure out what the scale factor is. I'm going to look here and see that the short side of this triangle is 2, and the short side of this triangle is 4. Therefore, this is an enlargement, and the ratio of 4 to 2 can be simplified to just say 2. The scale factor is 2. If I measure this side, this is 5, this is 10. Again, the scale factor is 2. Okay, let's remind ourselves how to dilate. By the way, this right here is pretty much, that's almost all of what you need to know for the test tomorrow. But if I look at dilations, when I'm dilating from the origin, I have to multiply the coordinates by the scale factor. It's very, very simple. And so I've got these coordinates. I've already written them down. I'm pretty sure they're correct. And so tomorrow on the test, when we're not using GeoGebra software, the first thing you need to do is decide that you need to dilate. And so I'm going to make a note to myself. I'm dilating, and the scale factor is 2. So again, just a note to ourselves. And we're going to update these coordinates. GeoGebra is going to do it magically. We want to make sure that we've got the right coordinates. So when I dilate by 2, again, my notes tell me to just multiply by the scale factor. 4 times 2 is 8. Negative 2 times 2 is negative 4. 4 times 2 is 8. 0 times 2 is 0. Negative 1 times 2 is negative 2. 0 times 2 is 0. So that should be where things get dilated to. So I'm going to dilate right now. I'm going to dilate this object about this point with a scale factor of 2. Okay, and as you can see, the new triangle is the same size as the triangle we want to map onto. So that's very good. So once I've done that, as you can see here, I've reminded myself I'm dilating first. Last I'm translating, so I'm either going to reflect or rotate at this point. To determine whether I need to reflect, sometimes you don't need to. You have to look at the orientation of the two triangles. So if I were to take this larger triangle and I were to turn it, if I were to push it up from this side, if I were to push it up so that it were standing up straight, you'd notice that this corner would be facing to the left, whereas in the red triangle is facing to the right. So their orientations are off. So we're going to need to reflect this object. It really doesn't matter which way I reflect it. I'm going to reflect it over a horizontal or a vertical line. In this case, it seems like it would be very easy to reflect it over the x-axis. So let's do that. Again, just make a note to ourselves, we're reflecting over the x-axis. Now, hopefully you've remembered this already, but if you don't, go back to the page of notes in your mind. If I reflect over the x-axis, the only thing that changes is the sign in front of the y. So all I'm going to do to these guys is change the sign in front of the y. Okay. 0 doesn't have a sign. I can make it negative 0. It's the same thing. Okay, so that was kind of a boring change, but that's how we do it. Okay, so I'm going to make a line through this point, and now I'm going to reflect our large triangle here